Greetings. Joseph Kursky here, geographer and education manager at ESRI, Environmental Systems Research Institute, and instructor at the University of Denver. Honored to be here with you to discuss fostering spatial citizenship through GIS. Fostering spatial citizenship through GIS. Human health, racial and social equity, population change, natural hazards, sustainable energy and agriculture, supply chain management, ocean acidification, water quality and quantity, land management, soil erosion. These and other 21st century issues are all spatial. They occur in specific areas, they cross multiple scales, they transcend numerous disciplines, they cross physical and political boundaries, they are complex, they change over space and time, and they increasingly affect our everyday lives and communities. To understand and solve 21st century issues requires spatial citizens. It requires tools that are built precisely for analyzing these problems over space and time. GIS, or Geographic Information Systems, also known as location analytics, geomatics, or geotechnologies. Spatial citizenship must begin in the educational system. Using geotechnology not only enables these problems to be solved, but it also helps students and professionals become more marketable in a variety of professions. Using geotechnology helps organizations also meet their goals and serve their lands, communities, customers, patrons, audience, researchers, stakeholders. Using geotechnology also helps organizations achieve the societal goals of a sustainable and vibrant Earth. Through it, individuals develop spatial thinking and data literacy skills. They work with real-time data. They build and crowdsource field surveys. They perform powerful spatial analytics. They share, communicate, and collaborate using web mapping applications such as story maps and dashboards. They build critical thinking and problem-solving skills. They become wiser, ethical decision makers, and ultimately change agents. Change agents. Isn't that what we are all seeking? What is spatial citizenship? As the Shin and Bednar's book states, an informed citizen has the capacity to participate in decision-making processes to address the common good for the community in which they live, for the country to which they belong, and for Earth which they inhabit. Citizenship education is preparation for citizen or civic engagement. As my colleagues Tom Baker, Mary Curtis, and Lisa Millsaps wrote in their chapter in the Shin and Bednar's book, a spatially literate citizenry must begin with young, spatially literate learners, capable of using technical and non-technical approaches to identify, explore, and solve real problems in thoughtful, critical ways. To build on this good work, I say that spatial citizenship is to actively practice the consideration and evaluation of the geographic patterns, relationships, and implications of issues and challenges at multiple scales over space and time. Citizenship education may also include the morals, ethics, and values that students experience in their studies as they interact within society. Moral and ethical actions result from a lifetime of learning and practice, both in school and out of school. However, it is in the early years of education that provide the basis for citizens to make sound moral judgments, ethical decisions, and reflect values that promote the common good. Grill and Jekyll, 2012, describe a competent spatial citizen as one who uses knowledge and skills to access and make sense of geoinformation in order to participate in democratic processes, and to make decisions taking into account the situations and circumstances encountered daily. Spica and Purdue, 2014, assert that spatial citizens are not passive. Rather, they are engaged and active members of society pursuing democracy. Citizenship can now be more participatory and justice-oriented, fluid rather than static. Globalization pushes its boundaries beyond the border of the nation-state to address international issues and interdependency. Spatial citizenship can be fostered through the use of rigorous tools and frequent use of rigorous tools such as GIS. For its first 40 years, GIS was largely a standalone technology operating on mainframes, mini-computers, and then on standalone workstations and PCs. An oft-cited complaint about GIS education for years was that it was too focused on buttonology. To be sure, learning GIS was no small task. To learn how to use it required one to be heavily invested in learning a set of commands and workflows, and thus to be integrally tied to the interface of commercial and open source GIS software. I submit, though, that there were always higher and more noble goals, even in those old clunky days. GIS has always been a thinker's tool. While learning GIS, one was also learning about a topic or issue while using rich data sets, whether it was about land cover change, natural hazards, transportation networks, economic inequality, health and wellness, population change, supply chains, energy, or as you see here, about river geomorphology in a couple of these slides. GIS has rapidly evolved into a platform. It has become more accessible, wizard-driven, cloud-based. Geotechnology workflows and models are shareable. With cloud-based platforms, geotechnology is becoming the nervous system for planet Earth, operating behind the scenes, just like your own body's nervous system. You wouldn't function without your nervous system. Same way with the world. Energy, supply chain, what you had to eat yesterday, etc., are all possible because of geotechnologies operating behind the scenes. That it enables efficient transportation, public safety, mitigation of natural hazards, environmental monitoring, and much more. Geotechnology is serving as this common language through interactive maps, infographics, and dashboards. A platform implies that you can build upon it, which is exactly what Platform GIS offers. You've all seen the JHU COVID dashboard. This is one of dozens, hundreds of dashboards created daily in the ArcGIS platform to help people and communities thrive and become resilient. This map-based, data-driven communication fosters collaboration and cooperation. Data is the fuel for GIS. Spatial data has also evolved. Increasingly open data policies, including geospatial data, geo-enabled IoT, Internet of Things, feeds, including those from stream gauges, seismic stations, ocean buoys, traffic cams, wildlife perimeters, for example, and portal technologies such as ArcGIS Hub from Esri and artificial intelligence and machine learning algorithms have combined to create a truly big data world. These data, 2D and 3D web maps, other maps, and imagery are instantly able to be streamed and used in GIS software such as ArcGIS Online and ArcGIS Pro. Ways to use and learn geotechnologies has also rapidly advanced. Massive open online courses or MOOCs from universities, from Esri, from others are available. Books and ebooks, videos, tutorials, help documentation have vastly shortened the time required for people to learn and advance their geotechnology skills. New ways of learning include degrees, certificate programs, certifications, and micro-credentials. More about learning resources later. If we agree that one of our chief goals in education is to prepare students to be well-informed citizens capable of making informed civic decisions, and if we agree that the Carnegie Report's trifold learning goals of skills, knowledge, and attitudes are important, then I submit that spatial thinking and the application of geotechnologies are key to enabling educators and students to achieve these goals. I see increasing geoliteracy as one of the main objectives of spatial citizenship. Geoliteracy includes three components: content knowledge, geotechnology, data and communication skills, and the geographic holistic thinking framework. This is the framework that I have noted time and time again as I have worked with students and faculty over the past 25 years. Understanding the connections between the biosphere, hydrosphere, lithosphere, atmosphere, and anthrosphere. This gives them, in my view, a distinct advantage as they pursue and use geotechnology. The most important component of geotechnology is people. People. And the most important geotechnology tool is not overlay or geocoding or buffering, but rather this tool right here, your brain. We need people with skills in spatial thinking and geotechnologies across a wide diversity of disciplines to build a geoliterate world, a world in which people are empowered to make wise decisions to make a smarter, healthier, more sustainable society happen. I submit to you all that instilling geoliteracy skills must begin in the educational system. The problems we face, folks, are just too serious to pin it all on the job training after a person enters the workforce. We've got to start with education. A key way of teaching and learning spatial citizenship is in an applied ways. Geotechnology offers the ability for learners to ask a question, frame a problem, gather and assess data, perform analysis, adjust variables and inputs as needed, propose solutions, and act on the newfound knowledge. This leads to additional questions and the cycle continues. Here, what are the patterns of households in my city with limited or no internet access? What is the relationship of those patterns to housing, age, median income, diversity, and other variables? Why does it matter, and what can be done about it? Said in another way, what's where, why is it there, and why should we care? What's where, why is it there, and why should we care? About traffic accidents in my community, for example. Mapping and visualization permit the visual analysis and discussion of civic spatial patterns that range from voting to planning community projects. Say Bednars and Bednars in Chapter 5 of the book Spatial Citizenship Education. Geoliteracy and spatial citizenship through geotechnology is making steady progress across all levels in education worldwide. Teachers and students in thousands of primary and secondary schools around the world use geotechnology to teach biology, earth science, technology, mathematics, geography, history, and other subjects. They use interactive online maps and lessons that my team and others create for students to engage in inquiry. They learn about plate tectonics, soil erosion, weather and climate, ecoregions and biomes, sources of energy, land use and land cover, population. They learn how all of these variables interact. They develop a holistic sense of the interconnectedness, again, of the biosphere, lithosphere, atmosphere, hydrosphere, and anthrosphere. They also look at cycles, the carbon cycle, the hydrologic cycle, and so they understand how those cycles interact with these spheres. In primary and secondary schools and in higher education, tribal, technical, and community colleges and universities, educators are teaching with geotechnology and teaching about geotechnology. Teaching with geotechnology means using digital maps and spatial analysis tools to teach fundamentals in a disciplinary content area. This is what occurs mainly in primary and secondary schools, in science and social studies classrooms, for example. Teaching about geotechnology means to teach about the technology itself, developing geodatabases, symbolizing and classifying data, serving spatial data, working with the mapping APIs, building code, and so on. Higher education instructors teach with geotechnology in biology, chemistry, civil engineering, environmental science, investigating such topics as river systems, the hydrologic cycle, ecological succession, invasive species, wildfires, floods, earthquakes, etc. Even more commonly, thousands of these institutions worldwide are teaching about geotechnology in GI science, data science, remote sensing, and other courses, certificate programs, and degree programs. One example of a set of interactive dynamic maps that can foster spatial citizenship and that are easy to create and analyze are policy maps on equity, demographics, housing, health, behavior, and much more at multiple scales. These maps are interactive. The scale, the symbology, classification method, and other aspects can be changed and altered. They can be shared and added to multimedia presentations such as dashboards and story maps. Spatial citizenship is best taught in space, in the field. Modern GIS-based field tools, some of which are crowdsourceable, such as Survey 123, web mapping applications such as story maps, spatial analysis, coding with Jupyter notebooks, serving and sharing data, creating infographics and dashboards, setting up and maintaining servers and hubs, etc. GIS is also being taught in a wider way, that is, in more disciplines throughout the academy. In particular, GIS is making progress in data science, digital humanities, business, where it's usually called location analytics, health sciences, where it's usually called health informatics, city planning, and in the AEC space, architecture, engineering, and construction, in particular civil engineering. This is occurring as part of innovation and rebranding in universities, workforce development initiatives, changing societal expectations, and the evolution of the geotechnologies themselves. On the latter aspect, Business Analyst Web is being used in supply chain management courses and marketing courses. ArcGIS Urban is being used in civil engineering and planning courses, and Survey 123 is being used in sociology and archaeology courses. Why? These increasingly accessible and useful tools can be added to the tool belt of a person studying to be a marketing analyst, a planner, or an archaeologist, respectively, without requiring that person to put his or her career plans on hold for 1 or 2 years while they learned GIS. Now, make sure you don't miss my mention of crowdsourcing. This is powerful and opens up many doors. Citizen science isn't new. It has roots in Audubon and birding natural movements of the 19th century. And crowdsourcing in mapping isn't new either. Indeed, Michael Goodchild wrote an article entitled Citizens as Sensors as 20 years ago, coining the phrase volunteered geographic information. I cannot overemphasize the key role that the advent of geotechnology in this cloud-based platform has made here. With ArcGIS Online, in literally less than a minute, an instructor and students can pull up live stream gauging data from stream gauges, map of rivers and watersheds, population density, and real-time weather to analyze potential floods. They can analyze the 3D relationship of current wildfire perimeters to land use, land cover, slope, aspect, the direction of slope, elevation, and soil moisture. They can join local data to census demographics from the Living Atlas of the World to analyze local population, income, and consumer behavior. They can analyze change on lands and in communities over space and time, variables about health, education, and access to safe drinking water, and other UN Sustainable Development Goal variables, SDGs. They can create a field survey about tree species, dangerous intersections, or water quality with Survey 123, crowdsource it, collect data into it, map the results, analyze the resulting patterns, and create a story map that communicates their findings and recommendations. It's not just teaching about the technology, but rather the societal implications of that technology, including the ethics and other issues that are bound up in using data, scientific research, and communicating about that research. I contend that this is an integral part of spatial citizenship education. Folks, the evidence is pouring in that students using these tools, data sets, and methods are becoming change agents, not just after they graduate, but even while they are still students. I encourage you, choose the most appropriate tools for the job of teaching spatial citizenship. I believe GIS is a key tool to accomplish this. Keep asking these questions. What if we change the scale, the variables map, the symbology, the classification, etc.? Why does this pattern, for example, look the way it does? And why does it matter? And keep saying, according to this data that we have at our fingertips. Remember, it's all dependent on the data that you have. Understanding that data. So according to this data, we can say that ... Keep the geographic inquiry process at the forefront, I implore you. The action item here is key to spatial citizenship, as is the asking of the original questions. And that cycle continues, leads to asking additional questions. But that action item, okay, now that we've gained this newfound knowledge based on our analysis, what are we going to do about it? About the community gardens, about the urban greenway, about the litter, about the dangerous intersections, etc. Keep learning. A plethora of resources are available for developing geoliteracy and spatiotemporal analysis skills from primary to university and lifelong learning, and in many formats, instructor-led activities, self-paced activities. Resources include lessons, videos, readings on the ESRI Academy, as individual lessons and also in learning pathways that you can pursue. ESRI Press offers hundreds of books and ebooks on how to use GIS, how to analyze imagery, specific applications in land use, health, criminal justice, hydrology, and many other fields. The Learn ArcGIS lesson library includes hundreds of hands-on activities waiting for you to dive in and investigate. ESRI MOOCs, massive open online courses, not only offer you the ability to learn, but to network with fellow colleagues as you go through these free 6-week courses. The instructors are knowledgeable and they're also fun and passionate about what they do and about teaching. The Geospatial Technology Competency Model from my colleagues at the Geotech Center is a tool that you can use to periodically assess your own progress in learning geotechnology. I especially like the personal competencies that undergird the pyramid. Are you ethical? Are you organized? Can you work with data? The Spatial Reserves data blog and book from Jill Clark and I digs into deeply about data. How can I find data? How do I know if it's any good? And societal issues, free versus fee data, location privacy, and much more, ethics, etc. It is aimed at helping you to become a critical consumer of data. We are living in amazing map-enriched times, but maps must be treated and created with care and respect. Most importantly, develop and nurture those communities of learning. We all need each other to move forward. Let's touch on pathways forward for a moment, shall we? Increasing geoliteracy and spatial citizenship at a more rapid pace cannot just rely on tools or data, and it cannot just rely on us here on the education team here at ESRI. It will require ongoing collaboration between schools, higher education, education agencies at all levels and disciplines, industries such as GIS companies such as ESRI, content developers, publishing houses, and nonprofit education and science organizations. A group of colleagues and myself outlined the gaps in an article in the journal Research in Geographic Education Online. To hasten progress, I recommend a distributed set of R&D centers housed in colleges, funded and supported to do for spatial citizenship what the NCGIA, or National Center for Geographic Information and Analysis, did in the early 1990s. NCGIA turned GIS systems into GIS science with its own research agenda, curricular resources, and a network of faculty scholars. To advance geoliteracy and spatial citizenship, the center I propose develops curricular resources, ensures access to spatial data, promotes research in the implementation and effectiveness of geotechnology in education, and creates and sustains a network of instructors, researchers, administrators, and students who can advance this effort. All 21st century problems are spatial. Solving spatial problems requires spatial thinking and GIS. Spatial thinking must begin in the education system. Resources that advance spatial citizenship education through GIS are available and growing. Spatial citizenship is making progress worldwide. However, collaboration is needed to hasten adoption. Thank you.